Welcome to our Asteroid Day 2020 digital panel, Target Asteroid, How to Move an Incoming Space Rock. We know of more than 1 million asteroids, a small fraction of which cross Earth's orbit. Now, occasionally, Earth can be in the wrong place at the wrong time and take a hit. That's what happened in the Tunguska region of Siberia on the 30th of June, 1908. And that's the anniversary that we're actually marking with Asteroid Day. This panel is about the research that's going into the prevention of another strike. NASA's Double Asteroid Redirection Test Mission, or DART, and the European Space Agency's Hera mission will try to change the orbit of a small asteroid and then precisely measure its effects. NASA will crash the DART spacecraft into a small asteroid known as Didymos B, or Didymoon. And then ESA's Hera spacecraft comes in to map the resulting impact crater and measure the asteroid's mass. Hera will also launch 2 CubeSats that will carry out crucial scientific studies before touching down on the asteroid's surface. Together with support from ground-based telescopes, this joint mission will begin the process of turning asteroid deflection into a well-understood planetary defense technique. I'm Alan Boyle, Aerospace and Science Editor for GeekWire, and joining me to talk about this fascinating subject today are Dr. Tom Jones, planetary scientist and NASA astronaut, Hannah Goldberg, a systems engineer at GomSpace in Aalborg, Denmark, Michèle Lavagna, a professor in flight mechanics at Politecnico di Milano, and Margo Fuchs, CEO and owner of the space technology company OHB. Tom, deflecting an asteroid sounds like a pretty difficult thing to do. What are some of the options?
Well, to deflect an asteroid away from a possible impact with Earth, you can think of the big problem as just making it miss its appointment with the Earth. So if we get early warning of an asteroid on a collision course with the Earth out 5, 10, 15 years, then that gives us time to develop a spacecraft and apply some of the techniques that have been talked about to deflect an asteroid. You know, the one that you've referenced already is called kinetic impact, where you basically shoot the asteroid with a bullet, a very high speed bullet, your spacecraft, and that transfers enough momentum, changing the speed or the velocity of the asteroid so that it shows up late or early for its appointment to smack the Earth. And so that transfer of momentum from the kinetic impact is what does the job. There are a couple of other practical alternatives. If you have a lot of lead time and the asteroid's fairly small, you can park your spacecraft right next to the big asteroid and then just hover there. And the mutual gravitational attraction between the asteroid and your little spacecraft is enough over a period of months or even years to pull or tug that little asteroid away from its appointment with Earth. So you make it show up early or you make it show up late and Earth goes unscathed. And then I think the final Hollywood solution that we've all seen is the nuclear explosive solution, where you blast the asteroid with a nuclear device. And that actually has some good physics behind it, but you don't want to blow it into a million pieces like they do in the movies. What you want to do is fry with a nuclear explosion one side of the asteroid. And that generates a puff of a giant jet of vapor coming off the asteroid from the intense heat, X-rays and neutrons of the nuclear explosion. And that puff of vapor will shoot the asteroid in the opposite direction, just Newton's third law. And again, you'll speed it up or slow the asteroid down and you make it miss its appointment with Earth. And then there's some other exotic techniques that we can talk about, but those are the 3 leading contenders right now.
I have a feeling we're going to get back into the Hollywood solution a little bit later in this presentation. But for now, could you tell us a little more about DART and what that's expected to do?
Yeah, this is a mission that's very exciting, close to my heart. You know, I visited the space station. We had our asteroid, we had our space station up there as our target, and our space shuttle took us to the space station. It required very precise navigation, very gentle closing rates to dock with the space station. Well, DART is the kinetic impact technique, and it doesn't come in closely, very slowly and gently. It zooms right in at a speed of about 6.5 kilometers per second. But the navigation techniques are similar to those that we use in human spaceflight. And also, it's applications from missile interceptions technology that we can use to strike this asteroid. So DART is a small spacecraft about the size of a small automobile, and it's designed to launch next year in the summer of 2021. And then a little over a year after that, it's going to strike a small moon around an asteroid called Didymos. And as you mentioned, the smaller satellite, Didymos, which is only about 160 meters across, is the target for this demonstration. And the reason we chose to, NASA and the Applied Physics Lab, which is building the spacecraft, the reason they chose to not strike the big 800-meter asteroid versus the small moonlet of 160 meters is because it's easier to measure a deflection change in speed if you strike a smaller, less massive object. So the idea is to target this little satellite circling Didymos and then change its orbital period around the primary about 10 minutes. And that 10-minute change in its orbit around the Didymos can be measured from Earth 7 million miles away in September of 22.
Great. Now, Michèle, you're also involved with the Hera mission with the Italian CubeSat called LiCiaCube. Could you tell us first what a CubeSat is and then how the LiCia mission works with DART?
Of course. So the CubeSat is basically a satellite, very small. So we are talking about a size like a shoebox, but with the capabilities of a complex satellite as well. So the idea with LiCiaCube is basically to support the DART mission. This is a CubeSat mission based and designed in Italy together with the collaboration of the two national agencies, so NASA from one side for DART and the Italian Space Agency from the other side. And you can imagine that if you have a satellite that is impacting on a stone in deep space, nobody is going to see what is going to happen during the impact because the spacecraft is crashing on the asteroids. So the role of this small shoe box that stays on the shoulder of DART just up to the arrival at the asteroids and then is detached 10 days before, is to be the eye of DART in some sense. So it will witness the impact of the satellites on the asteroids and will have the chance to collect images of those few minutes at the impact and after the impact. So this is a unique opportunity to an mutation asteroid occurring at the impact. And from the scientific point of view, this will help understanding the composition of the asteroids, the effects of the impact, and the behavior of DART during the asteroid's impacts as well. And this will be also from the technological point of view a very, let's say, exciting challenge because it's the first time that such a small spacecraft will leave the environment of the Earth that is a bit protected from the harsh environment and will experience the complexity of the deep space. So challenging from the science, but also from the technological point of view.
Fantastic. That sounds like a great show to look forward to. Several years after the impact, there will be another show when the Hera mission arrives to take follow-up readings. Marco, you and your company have a big responsibility in this mission because OHB is the prime contractor. Tell us what that means and what the spacecraft will do.
Yes, thanks, Alan. Yeah, we're very happy as OHB that we have been selected as the prime contractor for the Hera mission. That's a European mission funded by the European Space Agency, ESA. It's led by German industry, and there was a competition some time ago where OHB was able to succeed. So we're very happy to have that responsibility. And of course, as we heard earlier, that's the European contribution. And then later on, we will visit the asteroids and we will measure the impact that DART has on the asteroid. And of course, we're trying to then, or the scientific payloads are trying to then measure and establish exactly what was the success, how DART impacted the asteroid, the smaller of the two asteroids. And Europe, together, 13 countries are jointly funding that mission. So it's exciting because it has a very tight schedule because we have to make that launch date. And it was only decided last November. So we heard from Thomas that the DART mission will launch already in the summer of 21. So we are coming late, but we have to make sure that we are reaching the asteroids because they are moving away from Earth. So distance is getting bigger, so we need to speed up and be on time.
Fantastic. In addition to its own suite of instruments, Hera will be carrying 2 CubeSats that it'll deploy once it arrives at Didymos. One of those CubeSats is called Juventus, and that's the mission that you're working on, Hannah. Why don't you tell us a little bit more about that mission?
Sure, happy to. So Juventus is another what's called a 6-unit CubeSat, so very similar to the shoebox size of the Lucia CubeSat that was talked about earlier. And so what we will do is Hera will do all of the work in getting us to the asteroid, so we don't need to do that ourselves. And once there, drop off Juventus into the Didymos asteroid system. We will provide the really exciting measurement of the first ever information regarding the interior of an asteroid. We do that with our primary payload is a low frequency radar. And that radar has the ability to penetrate inside the asteroid and tell us about its interior composition. So is it made of one big monolithic structure or a bunch of different smaller rocks? And this interior probing through the radar measurements will be able to give us a lot of information to complement that of the Hera observations to tell us how these binary asteroids are formed and a little bit more about them.
Well, I'm glad to get the correct pronunciation for Juventus, so I appreciate that. And you're also working on another standalone CubeSat mission called Margo. Tell us about the goals for that particular spacecraft and the challenges that you face as you're trying to get it into space.
Yep. So Margo is a slightly larger size, about the size of a small microwave oven. And what it will do is be the first ever CubeSat mission to be standalone by itself to an asteroid. So in many of these other missions, like Lucia Cube and Juventus, we ride along with a bigger spacecraft that does the work in the deep space navigation. And Margo has a very high performance electric propulsion system. So it will still piggyback on the launch vehicle rocket with a much bigger spacecraft, but it will stay in what's called a parking orbit and wait until it's the correct time to depart to head to a different asteroid target. So like many of these other bigger missions, we don't necessarily know which asteroid we'll go to yet. We'll be a bit flexible and have some candidates, but based on our launch time, we can then use our electric propulsion system to navigate to an asteroid ourselves and be completely independent in operations.
Great. Michèle, one of your specialties is trying to figure out how to navigate around asteroids. What are the challenges for that, and what are you learning about how to do it?
So it's really a challenge to stay nearby an object that you have to think is not known very precisely since the beginning. So you are going in the proximity of a natural object like the asteroids are, that you don't know quite well in shape, you don't know the dynamics of these objects, and you roughly know your positions because navigating in deep space is still a challenge and it's still something that is not done autonomously. And the risk that you add to this is that you are in proximity of small bodies, and proximity means around a kilometers or less, even meters, 100 of meters. So the chance to hit it is very high. And therefore, you have to identify ways, practical ways from the technology and the software point of view that allows you understanding quite quickly, because you have no time to solve the problem, where you precisely are with respect to the soil of the asteroids as well, to run your science, of course, but also to protect you from the risk of impacting, as mentioned. So in that sense, the optical navigation, so using a technique that is like our eyes, of course, enhanced with respect to the performance of a human beings, is one of the most promising. Not the only one, is a fusion of sensors and data to be collected, but this is a way, the way to pave for that.
Great. The fantastic thing about this panel is that there's so much going on with asteroids, and we've been talking about Hera and DART, but there's a lot more. And Marco, you're working not only with Hera, but also with an ESA mission called the FlyEye Telescope. Can you tell us a little bit more about your involvement in that mission?
Yes. Of course, the FlyEye Telescope is a telescope that is based on Earth and looks out to the universe, searching for asteroids. And that is obviously the other angle you can take. So we built the first of these telescopes that is installed in Italy, and we're preparing for a few more to do that. And obviously, you need to monitor asteroids from Earth so that you can detect them. ESA, the European Space Agency, is very active with a number of programs in that respect. And building the Hera mission in Germany, we're very happy to build the FlyEye telescopes from our Italian branch in Milano. So trying to be helpful from both sides of the angle.
Tom, I wanted to get back to Hollywood and the whole popular conception of the threat that asteroids pose and also what to do about them. You've been in this game for quite a while. Tell us what the public probably should know and they don't know about the asteroid threat and the promise of asteroids.
Oh, that's a great topic. I wish we had another half an hour to go into it all in great detail. But yeah, you know, the Earth has been bombarded by cosmic debris, creating craters on the surface of the Earth for the last 4.5 billion years, just as long as we've been a planet. The moon shows that evidence. It's our nearest neighbor in space, and we can see all of those pockmarks on the moon, those craters that have been created by this very same bombardment. Earth is just a more dynamic planet that renews itself and renews its crust, and so you don't see more than 190 craters or so that we know about on Earth today. But it's a global hazard. Small objects do run into us periodically. And in terms of one human's lifespan, not a big problem. We don't even know in history of anyone who's actually been killed by an asteroid impact. However, over the course of our species and over the course of 1,000 years, there will be enough impacts on the Earth that could cause us as a society a problem. So for example, just from our satellite data, we know that about 30 times a year, there's a Hiroshima-sized blast of an asteroid impact in the atmosphere. It doesn't make it to the ground or make a crater, but that blast occurs about 30 times a year from cosmic debris. So if a bigger one comes through, bigger than about 40 meters, it can make it all the way to the ground and cause damage to a city or a region. And we have to look ahead to define those objects and warn us of that pending threat, do something about them.
Great. Hannah, I wanted to play off that to talk about how asteroids could be a resource as well as a threat. That I know you were involved with Planetary Resources, which is a company that aim to take advantage of those space resources and maybe was ahead of its time, but that's certainly something that is a long-range possibility for humanity. How do you balance the methods to avoid asteroids with the methods to actually get to those asteroids and take advantage of them?
Yeah, sure. So the exciting thing is that just the fact that more and more of these asteroid missions exist, every time we've sent spacecraft to an asteroid, we've learned something new about them. And so the more of these missions that we get to learn more about the formation of the asteroid, the composition of the asteroids, we can use them not only for planetary protection purposes, but also for exploration and potential utilization of the types of resources they may have. So one exciting one is the potential of having water and what that does for space exploration and opening up a number of opportunities there. But that's why a mission like the Margo spacecraft is so enticing, because you can have a very small spacecraft go out and quite cheaply with the low cost operations compared to these much larger missions that take many, many years in the making. You can start sending these little exploration craft to more asteroids and learn more about them, and be precursor missions to find out what type of materials may exist.
Michèle, I wanted to ask you what the frontier for studying asteroids and finding ways to head them off might be. Are there new scientific perspectives that are coming to the light because of the studies that you and other people are conducting?
I would say that the techniques for pushing them off that has been mentioned by Tom are those that are in line and the more promising. I would say that there are some fancy other techniques that are not so scientifically valuable or technologically feasible. I think that the new frontiers from the asteroids point of view is somehow related with what Anna mentioned. So the exploitations of asteroids from the scientific point of view to understand the origin of life. So understanding and visiting those asteroids that are coming from very far, so object from the Kuiper belt, so the belt that stays at the limit of our solar system that are really difficult to get in. So this is the real frontier from the science, while from the technology, the frontier is the mining and the exploitations of the resources of those objects that are not so easy to land on because of lack of gravity. They are small. They sometimes are plenty of voids because they are a resemble of other stones put in together because of the dynamics of the gravity. And therefore, to land, stay there, drilling, scoping, getting the resources is really not easy because you touch the object and you are bounced back because you are not retained on the soil. And this opens a door to a lot of applied science that becomes technology for industry in the next decades. That is really exciting.
Great. And that leads me to Marco. I wanted to ask you about the future of missions to asteroids. Is this something that OHB intends to make a habit out of? And if we did need to divert an asteroid, how quickly could a mission be put together to do it?
Well, obviously, the last question depends on the approach of the asteroid. So, of course, we have to speed up if we see it very late because we need to be there before it hits Earth. So I guess one of the real challenges here is that there is a very firm schedule element in that. And this sounds a little bit like Hollywood, but that's really, if it becomes a real threat and there's the danger that an asteroid is approaching Earth, that defines the timing. What we can see on this DART Hera mission is that America and Europe works together, it's coordinated. So in case there ever comes a situation where it's really unclear if an asteroid is a threat to Earth, of course, I think the world would pull together and would define multiple efforts to do that.
Great. Tom, I wanted to turn to you for the last question because you're an astronaut. You've had this experience of seeing the Earth from space and getting that high altitude perspective. And in fact, at one time, NASA was planning on doing a mission that would send astronauts to a near-Earth asteroid. I'd love to hear your perspective on the possibility of actually sending people to these asteroids and what it would be like. Is that something that you could imagine yourself doing?
Well, I'd love to sign up for a mission like that, Alan. It's exciting to think that the more we learn about asteroids from a planetary defense perspective and from a scientific perspective, the more that feeds into our ability to use their resources and use their physical locations in space as really literally stepping stones out to Mars, for example. So we're going to operate, I hope, on the moon in the next 5 years and learn some more about operating on another planet. But Mars is a different proposition, very much more difficult to get to. That search for life out there is a reason to go to Mars, but it's going to take a 2 to 3 year mission, lots of hazards along the way. Maybe some smaller steps out towards Mars, visiting the nearby asteroids would give us the experience, the vital risk reduction that we would need to make it safe for humans to plunge out into the depths of the solar system to Mars. So if we go to a small asteroid, we get not only a scientific bonanza and maybe tap into water resources on that asteroid for the future. But we also learn how to operate around small, very low gravity bodies like the moons of Mars, Phobos and Deimos. So we might think of an asteroid mission relatively close to the Earth, maybe a few months out, a few months back, as a way to rehearse for the larger campaigns of exploring Mars.
That is such a fantastic point, that we're talking about asteroids today for Asteroid Day, but it's really not just about asteroids. It's about exploration and protecting the Earth and taking advantage of space resources. And I'm so glad we had a chance to touch on all of that during today's panel. Thank you so much to our speakers for their insights into this big topic. Probably the one thing that the general public knows about asteroids is that they might be able to kill us someday. And so we don't want to go the way of the dinosaurs. We want to find a way to use science and technology to keep things going and push out into the broader cosmos. And so thank you so much for being part of this panel, and thanks to our viewers for sticking with us and learning more about asteroids. And so have a great Asteroid Day. Watch the other presentations that are online, and until next time, watch the skies.